Bismillahirrahmanirrahim. Assalamu alaikum all of you. My name is Palvasha Arzu. I am a student of University of Management and Technology, and today I'm going to present my topic on intelligent manufacturing of conductive inks by silver nanoparticles. Okay, let's start. Moving toward the first slide, here it is the introduction of my topic, and it basically consists of 4 headings. The first heading is overview, the second one is key material, the third one is objective, and the fourth one is significance. Okay, in the first heading of overview, we will answer this question that why we are going to produce the conductive inks and what is the basic reason for the production of the conductive inks. So the answer is that rapid growth in the flexible and the printable electronic has driven the development of conductive inks. Basically, in the recent years, there is a rapid growth in the use of these flexible and the printable electronics. So that's why we are forced to produce the conductive inks. This is the simple answer of this question. Coming toward the second one is key material. What is the key material that is used in the production of this conductive ink? So basically, the silver nanoparticles are the key material that are used in the production of the conductive inks. And why we use the silver nanoparticles? We use the silver nanoparticle because of the two reasons, because of the superior electrical and the thermal conductivity. Coming toward the third heading, that is objective. Okay, basically explore intelligent manufacturing processes, challenges and application. So in this presentation, we will discuss some intelligent manufacturing processes that are involved for the production of nanoparticles of silver, and then some also procedures that are also used for the production of the conductive ink as well. During this, we will also discuss some challenges that we faced during this procedure, and we will discuss the applications of the different procedures as well in this presentation. Coming toward the next heading, that is the significance. So it offers the solutions for advancing modern electronic devices, sensors and energy system. So what is the significance of this presentation is, it offers solutions for advancing the modern electronic devices, sensors and energy systems. Coming toward the next slide, why conductive inks? Why conductive inks are used? First of all, we will have the definition of the conductive inks. What are conductive inks? The conductive ink is a printable material that can conduct electricity and is made by mixing conductive particles such as silver, copper or carbon into ink. But here we will use the silver as the conductive particles. Okay. Now coming toward the next heading, demand. Okay. The demand is that essential for flexible electronics, photovoltaics, wearable technology and sensors. There is the demand of the conductive inks in the market because it is essential for these three technologies, for the flexible electronics, for the photovoltaics and wearable technology and sensors as well. Okay, here we will discuss some advantages of silvers. So the first and the foremost advantage of the silver is that its high conductivity and thermal stability. Due to these reasons, we are going to use the silver nanoparticles. Coming toward the next is resistance to oxidation compared to copper and carbon based ink. And as you know, it is more resistant to oxygen. It is more resistant to oxidation as compared to the other element like copper and the carbon based product that are used in the production of ink. So therefore, silver is a good option. Coming toward the market potential, that is expected growth in the printed electronics industry reaching multi-billion-dollar valuation. What does it mean? It basically points out the growing industry of printed electronics expected to reach billions in market value, showing the high demand for conductive inks. Coming toward the next slide, Here it is the synthesis of the silver nanoparticles. Okay? Basically, different techniques are used for the production of the silver nanoparticles, which are then further used for the production of the conductive inks. The four basic methods are: first one is chemical reduction, second one is physical methods, third one is electrochemical processes, fourth one is biological or green synthesis. Okay, let's have a view one by one. The first one is chemical reduction. So in this method, we uses the reducing agents to form the nanoparticles. And in the physical methods, it involves the top to down approaches like laser ablation and the evaporation condensation. The third method for the production of the silver nanoparticles is electrochemical processes. In this process, electrical energy is basically converted into the chemical bond, and then it is utilized for the manufacturing of the nanoparticles. The fourth procedure is biological or green synthesis. So it basically uses plant, bacteria or algae extract for the production of the silver nanoparticles. And the last heading of the slide is basically focus. Okay? Achieving nanoparticles with the optimal size, stability and conductivity. In this, all these procedures, our main focus is that we have to achieve the nanoparticles with the particular properties, with the optimal size, with the stability and with the particular conductivity. Coming toward the next slide, that is the chemical reduction method. Now we will have an overview of each of the method for the production of the nanoparticle one by one in detail. The first method is chemical reduction method. Okay, the chemical reduction method, it basically consists of four headings. The first one is the process. So in this process, bottom up approach using reducing agent is employed to form the nanoparticles from the silver salts. So therefore silver salts are basically used, and also a reducing agent is also used in this method. Okay. What is the advantage of using this method? The first advantage is that it is cost effective, it is scalable, and it is quite simple as compared to the other procedures, and there are no such conditions which we have to maintain for this procedure. And what are the challenges for this method? The first one is that it requires stabilizers to prevent agglomeration. For example, the clumping may occur during this procedure. So in order to avoid clumping, we are going to apply some kind of stabilizer in this procedure. And the second one is that it is sensitive to environmental condition. This procedure is very sensitive to the normal environmental condition. For example, it is very sensitive to the exposure to oxygen. Coming toward the next heading, that is key examples. And what are the key examples of this procedure? These are sodium borohydrate and ascorbic acids as reducing agents. Coming toward the next slide, that is about the physical methods. Okay, let's have a view about the physical methods. The key techniques. What are the key techniques that are employed during the physical methods for the production of the nanoparticles, as you know? The first one is laser ablation. And what is happening in the laser ablation? High energy lasers break the bulk particles into nanoparticles. In this method, the bulk particles are converted into the nanoparticles like top to bottom approach. Coming toward the second one is that is evaporation to condensation. And in this procedure, plasma or heat creates a nanoparticle vapor that condenses on substrate. In this case, heat is either you're gonna use plasma. As you know, plasma is the fourth state of matter. It is charged gas. Either plasma or heat is going to produce the nanoparticle vapor, and these vapor are then condenses on the substrate and result in the manufacturing of the nanoparticles. Coming toward the next heading, that is benefits. What are the benefits of this method? The benefits are basically it produces highly pure nanoparticle. As you know, there is no other procedure, so that here there is no presence of contaminant in this procedure. So therefore you can say that the nanoparticles that is produced by this method are not having any kinds of additives. Drawback. What are the drawbacks of this procedure? The drawbacks are it is very high energy consuming procedure. It requires a very high amount of energy. So therefore we are not going to use this method. And the second one is that it requires specialized equipments as well. So therefore, due to these two reasons, we are not going to employ these two methods. Let's have a view about the applications. Application ideal for high precision nanoparticle requirement. This method is basically used for the production of those nanoparticles in which there is a high precision of nanoparticle. Okay, coming toward the next method. Okay, as you know that the biological synthesis is also known as the green synthesis. Why the biological synthesis is also known as green synthesis? Because it is also eco-friendly. Okay, let's have a look of the biological synthesis. It basically consists of four headings. The first one is eco-friendly approach, the second one is advantages, the third one is challenges, and the fourth one is examples. Okay, let's have a look why it is eco-friendly approach. Okay, as you know that this method utilizes the plant extracts, algae or bacteria for the production of nanoparticles. So therefore that's why this method is eco-friendly. This method don't use any kind of material for the manufacturing of nanoparticles. So that's why it's quite eco-friendly. Coming toward the advantages. What are the advantages of this method? First one is biocompatibility. Biocompatibility ensures safety for medical application. So such type of nanoparticles can be used for the medical application. Okay. Coming toward the second advantage, that is reduced environmental impact compared to the chemical synthesis. Obviously, as you know, this procedure don't involve much chemical, so therefore it is also having some environmental impact as compared to the other chemical synthesis procedures. Coming toward the next challenges, there are certain challenges as well. The first one is that inconsistent particle size. The particles that are produced by this procedure are basically inconsistent in size. Okay, and the second one is that dependency on biological growth condition. It also depends on which kind of growth condition you're gonna provide them, and that will ensures and that will affects the type of nanoparticles that are produced. Okay, and will also affect the other product. Coming toward the example, the examples are aloe vera extract and microbial procedures that are employed during these processes. Coming toward the next slide, that is challenges in manufacturing. What are the challenges that we are going to face during the production? The first challenge is oxidation. Okay, what do this procedure do? The first one is it reduces ink conductivity and lifespan. Okay, so the oxidant takes places that reduces the ink conductivity. And what is the solution for this is? The solution for this is that use of stabilizers and controlled environment. So for protecting the ink from reduction, we will use certain stabilizer and we will use certain controlled environment. Okay, coming toward the second challenge is that agglomeration. For example, it will cause this clumping, clogging, dispensers and print defects. Okay? So all these problems can be overcome, and the solution is that by adding capping agents or surfactant. So if we use capping agent or surfactant, all these problems can be tackled. Coming toward the next issue, that is cost. High material and equipment expenses. Obviously, as we have already studied that some of the methods for the production of the nanomaterial involve some high material and the equipment. So that's why it will also so therefore the issue of the cost is also there for us. So therefore how it is treated? Future trends. Explore cost-effective alternatives and optimized process. For this case, we will employ cost-effective procedures and we will use cost-effective alternative and the processes for the production of the nanoparticles. Coming toward the next slide, it is about ink formulation components. Okay. Basically, it consists of key elements and the importance of all these key elements. We will discuss these key elements one by one. The first one is conductive materials. And as you know, we have used silver nanoparticles for the electrical performance. We have employed the silver nanoparticles as a conductive material in the production of the conductive inks because of its excellent electrical performance. Coming toward the second one is that we have also used a polymer. Polyvinyl pyrrolidone (PVP) is used as a stabilizer for the production of the conductive inks. The third one is solvent. The solvent is also another key element for the production of the ink. Organic, for example, MEK or water-based options for printing compatibility. All these solvents are used and they are the compulsory elements for the production of the conductive inks. Also, there is another key element, that is additives. And what do? They control the viscosity, adhesion and surface tension of our conductive ink. And what is the overall importance of all these materials are balancing stability, conductivity and the printability of our conductive inks. Coming toward the next slide, that is role of AI and machine learning. What is the role of artificial intelligence and machine learning in the production of conductive inks? So let's have some discussion about this topic as well. First one is optimization. It enhances the synthesis and the formulation process. Obviously, as you know, if we are going to employ artificial intelligence and machine learning in the procedures that are used for the formulation, so obviously it will enhance the synthesis procedure and it will also give us a more precise product. Coming toward the next is key approaches. The key approaches are basically three. The first one is predictive modeling. It forecasts particle size, yield and distribution. It deals with all these points. The next one is reinforcement learning. It relatively optimizes the synthesis condition. It deals with the synthesis condition that are used in this procedure. The third one is process automation. Real-time adjustment for the consistent results is basically done by the process automation. And the last, the benefits is that it reduces the trial and error and it also increases the reproducibility of our procedure and it also minimizes the cost, as you know. Coming toward the next slide, that is the printing techniques. Okay, now we will discuss some printing techniques in which the conductive inks are used. First, there are some techniques in which the conductive inks are used. We will discuss some of them. Methods. The first one is inkjet printing. The second one is screen printing. The third one is 3D printing. The fourth one is flexographic printing. And we will have the detail of each of these printing techniques. Inkjet printing. In this procedure, precision placement of the conductive patterns are involved. The second one, screen printing. It is cost effective for bulk manufacturing and that's why in this case conductive ink is used for the production of cost effective product. The third one is 3D printing. It enables intricate designs and flexible geometries. And in such cases, the conductive inks are also employed for the production of 3D printing. The next one is flexographic printing. This kind of printing involves a high-speed production or for the industrial application. Okay? During this printing, the production is very high speed and that's why it is basically done at the industrial level. The last heading is emerging trend. What is the emerging trend of all these printing techniques? that is combining multiple printing methods for hybrid application. Some of these printings are also hybrid, or they also collaborate with each other for the hybrid applications. Coming toward the next is application, overall applications of the conductor. Okay, let's have a view on the application also. It basically consists of the two headings, key areas and example. First of all, the key areas are, first area is about the flexible electronics, where the wearable devices and foldable screens are produced by using such products. The next one is RFID system, intelligent packaging and transportation of tickets is basically done by this procedure. The next one is medical sensors. Biosensors for real-time monitoring is basically done by this procedure. Photovoltaics. Thin film of solar cells are produced. The next one is wearable technology. Smart textiles, fitness trackers are usually produced. The examples: membrane touch switches and printed batteries are produced by using these inks. And these are the application where the conductive inks are used. Now coming toward the next slide, that is advantages of silver-based ink. What are the advantages of particular silver-based ink? Here are some advantages. The first one is high conductivity. It ensures reliable performance in electrical application. Obviously, silver is highly conductive, so therefore it will give a reliable performance in electrical application. Coming toward the next is oxidation resistance. As we have already discussed that it is very resistant to oxidation as compared to the copper and other carbon based ink. So therefore it will give a longer shelf life as compared to the copper inks. Coming toward the third heading is versatility, suitable for various substrates like papers, PET and glass. So versatility also makes it more beneficial as compared to the other inks. Scalability supports industrial scale production with consistent quality, as this is another advantage of silver based ink. Coming toward the next slide, that is environmental considerations. Okay, environmental consideration. As you know, we have to keep this aspect in the mind as well. The first one is green synthesis. It minimizes toxic waste and use renewable resources, as during the procedure of the green synthesis, we are going to minimize some toxic waste and it also uses the renewable resources. So that's why it is also considered as a green synthesis method. Water-based ink. It is safer alternative to organic solvent as compared to the other organic solvent, as you know that they are more toxic as compared to the water-based. Coming toward the next heading, that is the focus areas. Reducing energy consumption and enhancing the biodegradability of components. Future vision. Fully sustainable production procedures. The future vision is that we are going to employ fully sustainable production procedures. Okay, now coming toward the next slide, that is about future prospects. Okay, first of all, the future prospects are research direction. Okay, how the research directions should be. Okay, according to the product and according to our topic for the production of the conductive inks by using silver nanoparticles. The first one is lowering the materials that are used for the production of, lowering the material cost that are used for the production of the conductive inks. Next one is improving nanoparticle synthesis scalability. And the next one is advancing AI driven automation, so that the product is produced with more accuracy and with less consumption of energy as well. Emerging applications: self-healing electronics, printed OLED displays, smart packaging for IoT integration, market projection, rapid expansion in the next decade. These are the some future prospects of our topic. Coming toward the next slide, that is advanced AI models in manufacturing. We have to employ some advanced artificial intelligence models in the manufacturing. The first one is that deep learning applications. What do? They predict the particle distribution patterns so that the particle distribution pattern is managed well, and it will result in the production of the product with more efficiency. And the next is analyzing synthesis pathway for cost efficiency. In this case, the pathways for the production of our product is maintained, and they can be altered or they can be changed, and they can be make more cost effective. Coming toward the next heading, that is case studies. Example of AI improving scalability in silver nanoparticle production. We have also a case study in this as well. And next is integration AI powered robots in continuous ink production lines. AI-powered robots in continuous ink production lines. AI robots should be employed so that the continuous ink production can be maintained. Coming toward the next slide, that is about addressing sustainability challenges. Okay, now we are also going to face some challenges for sustainability. Some of them are given below. The first one is eco-friendly alternatives. Transition to biodegradable polymers and renewable solvents. We have to maintain this transition. Next one is carbon footprint reduction. We have to reduce our carbon footprint. Streamlining process to minimize energy consumption. We have to go through the procedures again and again, and we have to maintain the process in such a way that it consumes minimum energy for the production of nanoparticle as well as for the production of the conductive inks as well. Now, the third one is circular economy. Recycling waste silver materials for the production of again the silver nanoparticles, and these nanoparticles are then again used for the production of conductive inks. Okay, now coming toward the next slide about hybrid printing techniques. Okay, as we have already discussed about the printing techniques, there are special kind of printing techniques, and these are known as hybrid printing techniques. And why they are known as hybrid? Because in these particular kinds of techniques, two or more than two printing techniques are mixed together for some desirable results. Let's have a view about the definition. The definition is combining multiple methods like inkjet and flexographic printing. So here they say that you're gonna use multiple methods like inkjet and flexographic printing together for the accomplishment of desirable procedures. Now let's have a look on the advantages. What are the advantages of this particular printing technique? The first advantage is that it will give us improved resolution and scalability. And the second one is that it reduced material wastage. Obviously, if two or more than two techniques are merged together, they will give us some advantages as we have already discussed. Now coming toward the application. Complex circuits, multi-layered designs, and high-performance wearable tech use all these hybrid printing techniques. Okay, let's have a view about this. The first one is healthcare. The sensors for personalized medical devices are being generated by using this method. Automotive. Enhanced safety features through the flexible circuits are produced. Consumer electronics. Innovations in AR/VR interferences. Energy sectors. Conductive inks in the next gen solar cells and energy storages. Now coming toward conclusion. Okay, now here I'm going to summarize my presentation, and the main point are given below. The first one is that silver nanoparticles are pivotal for the next gen conductive inks. Silver nanoparticles are very essential or are the main product for the production of conductive inks. The second one is that AI, artificial intelligence and machine learning revolutionize production processes. And the third one is applications span across industries, driving innovation. Closing note: collaborative efforts are essential to achieve cost-effective, scalable, and eco-friendly solutions. And that's all from my side. Okay, Allah Hafiz.